Hi, welcome back to my channel Easy to Learn. So this video I'm going to share an idea about the basic working of a microwave mixer. Basically, a mixer is a frequency translation device, or simply we can say it is a circuit which is going to mix two input signal and create a new signal, and the new signal frequency is equal to sum or the difference of the two input signal frequency. So this is the reason it is widely utilized in frequency shifting operation. And this is the schematic or symbolic representation of a microwave mixer, which consists of totally three ports, two input ports and one output port. And the two input signals are, one is the radio frequency signal, which is the message signal, and it's a low frequency signal, and the second input is the local oscillator signal, which is the large signal. Also, based on the component which is present inside, the mixer is classified into active mixer and passive mixer. If we are having a MOS device or PET based device inside, means that kind of mixer is called as active mixer. Or suppose if you are having a non-linear device or called a diode, then that kind of mixer is called as passive mixer. But nowadays, switching mixer, that is the active mixer, is widely utilized in the microwave mixer configuration. And basically, a mixer will perform two kind of operation. One is down conversion of frequency, another one is up conversion of frequency. But both the cases, the circuit configuration will look like this. That is, it consists of two input port with one output intermediate frequency. But the arrow indication is somewhat differ. The meaning is, if the intermediate frequency value is less than the second input signal frequency, that is the LO signal frequency, then that conversion is called as down conversion of frequency, which is represented by the notation FIF is equal to mode of FLO minus FRF. But if that intermediate frequency FIF value is higher than the second input signal frequency, that is the LO signal frequency, then that conversion is called as up conversion of frequency, and which is represented by the notation FRF2 equal to FLO plus FIF. But the very important point you have to notice is how a circuit going can mix two signal. Practically, in the mixer, what is going inside is multiplication of two signal. But how the multiplication is possible between two signal? I will tell you this thing based on one example. Consider you are having a MOS device and you are applying some sort of bias value, and based on that bias value you are making this MOS device as a conduction 1, and due to that you are getting a trans conductance value GM. This trans conductance is nothing but a ratio of change in output current with respect to change in input voltage which is applied at the gate terminal. Now in this time, you are introducing an RF signal as an input of this gate terminal of this MOS device. What will happen? According to the magnitude of this RF value, it is going to vary the transconductance value, or it is going to modulate the transconductance value. Okay, so next, how we can multiply with the another signal, I will tell you. Now you will connect another MOS device in the cascade configuration as shown in this diagram with the DC voltage with the LO signal. Consider this LO signal as a sinusoidal one or a square wave based on the application, but our example, consider it's a sinusoidal one, and the threshold value of this second MOS device is 0.3 volt. So what will happen? This LO is going to apply two kind of swing. One is positive swing, another one is the negative swing. So during the positive swing, if the voltage crossing above the threshold voltage, the second MOS device is going to on. And if the voltage value we are getting below the threshold voltage during the negative swing, what will happen? The MOS device is going to off. The meaning is you are connecting a transconductance value with a switch which is operated with the LO signal. If the switch is closed, you are conveying that LO information with the modulated transconductance value. That means you are going to mix that LO information with the RF information. So like that, when I am making the switch on and off, I can convey this LO information with the transconductance value in the different way. And after this, when you are connecting with the filter, and based on the filter configuration, you can get LO plus RF signal or LO minus RF in the frequency format. And this is the way they are carrying a multiplication process between two signal, that is the RF input signal as well as the LO signal. And suppose if you are applying a square wave as an LO signal with the RF signal, what will happen? The intermediate frequency waveform will look like this. And this is the way they are carrying the mixing process between two signal based on multiplication. I hope everyone understood this concept. Thank you so much for watching this video. If you like this video, kindly subscribe my channel.